Good day to all. I'm Dr. B. Yamini, Department of Computer Science and Engineering. In this session, we are going to have an extension of part 1 video called 3D viewing into part 2. In this video part 2, we are going to see about what is projections and different types of projections. Before getting into the topic, we must know what are the important viewing coordinate parameters. There are two important viewing coordinate parameters. They are viewpoint and viewplane. Viewpoint is eye point or viewing point. Let me consider this example. Here is the x-axis, y-axis, z-axis. All three converges at a point called as P0, and this P0 is called as eye point or viewing point. It is called as viewpoint. Viewplane. Viewplane is nothing but the surface on which the lines falls over in a normal vector as a normal vector n. Normal vector in sense it falls over perpendicularly, and this is what called as viewplane. Projection. What is a projection? It is the method of converting your 3D scene coordinates into 2D view plane coordinates is what called as projections. There are three different types of projections. The first one is parallel projection, isometric projection, perspective projection. Parallel projection means it discards z coordinates. So it will be considering only x coordinate and y coordinate. Let me consider this example in this. The object, that is parallel lines from each vertex on the object. This is the object, this is the vertex. From here the parallel lines falls over the view plane as such, but it will not go for convergence at the end. So parallel lines from each vertex on the object are extended until they intersect the view plane. They intersect the view plane. It will not get converged into the view plane. So direction of projection is parallel over here, and it is not the center of projection, which will not converge at the end. So this is what called as parallel projection is. Now, what are the features of the parallel projection? It is less realistic, good for exact measurement, angles not preserved. So then the types of parallel projection. The parallel projections are divided into many types. The main two types of parallel projection is orthographic projection and oblique projection. Based on the angle of incidence, that is angle of incident of line over the view plane, this parallel projection is divided into two, orthographic and oblique. In orthographic projection, the lines falls over the view plane exactly at 90 degree, but in oblique projection it need not to be at 90 degree, it may be of any angle. In orthographic projections, we are having many more subdivisions called top view, front view, side view. That is, by having 90 degree of view, we can see from the top, from the front, from the side. So top view, front and side view are orthographic projections. And also it includes axonometric projection. In all these three cases, top, front and side, we don't have more than one side. It will not show more than one side. But in axonometric projection, it shows more than one side of the object, even it is of 90 degree of incidence. It comes under isometric projection also, which shows more than one side of object. Oblique projection, it need not to be of what? 90 degree of incidence on the view plane. Then what angle it may use? There are two types of oblique projection. The one is cavalier and the other one is cabinet. Cavalier uses 45 degree, which shows the same size of the length of the object which you want to project on the view plane. But in the case of cabinet, it is 63.4 degree. If the length of the object is 10 centimeter, it will get projected onto the view plane as half of their actual length, that is 5 centimeter. Isometric projection. Parallel lines or parallelism of links are preserved in the isometric projections. Angles are not preserved at all in isometric projection, but it is a type of what? Orthographic projection. Next comes the perspective projection. This we'll see in the next video. Thank you.